Welcome to this explainer. Today, we are diving straight into Chapter 25, the observability landscape through a systems lens. We're going to cut right through all that deafening vendor noise out there and entirely reframe observability into a cohesive, strategic framework for your organization. Look, if you've been feeling completely overwhelmed by the endless sea of dashboards, competing tools, and marketing buzzwords lately, you are absolutely not alone. Engineering leaders everywhere are struggling to make sense of this space. So our goal today is to give you a really clear, unambiguous lens to view observability, not just as, another mandated IT expense or a shiny new toy, but as the fundamental, non-negotiable nervous system of your software delivery. We're going to break down exactly how to stop chasing features and start optimizing how your organization actually learns. All right, let's dive into this. Okay, take a look at this quote. The landscape has become a snarled, expensive mess. Let us be the first to say, we're sorry. This is not what we intended when we first coined the term. It is so important we acknowledge this right up front. The authors of our source material are actively apologizing here. And why? Because the term observability, which originally had a very specific, rigorous meaning rooted in mechanical engineering and control theory, well, it got completely hijacked. Over the last few years, marketing teams got hold of it and turned a pure engineering concept into this trendy buzzword used to sell the exact same legacy monitoring dashboards we've literally been using for a decade. The current landscape is just flooded. It's frustrating, and for a lot of teams, it's become entirely counter to its original purpose, which was simply to ask new questions of complex systems. Instead of clarity, the industry has just manufactured a ton of confusion. So here is our roadmap to guide you from this current, confusing marketplace toward a much clearer destination. We'll quickly run through the noisy observability landscape, applying a systems lens, development and operational loops, finding the missing loop, context, precision, and cardinality, and finally wrap up with viewing this as a strategic organizational investment. Let's start with Section 1, the noisy observability landscape. The sheer volume of niche categories being thrown at us right now is staggering. I mean, we are constantly bombarded with terms like data observability, AI observability, and now even large language model observability. Everyone is just desperately trying to slap the word observability onto their own specific silo. And because of this, engineering leaders are faced with all these overlapping vendor claims, where multiple tools promise the exact same outcome using the exact same marketing language. Yet the actual underlying products and the results they deliver in a real production environment are fantastically different. And honestly, this isn't just annoying, it actively harms engineering teams. When vendors promise the world using identical jargon for entirely different underlying technologies, it creates this highly noisy environment that completely obscures the true value of observability. It literally paralyzes decision makers. It leads them to buy redundant, disjointed tools, waste massive portions of their budget, and still end up with engineering teams that cannot actually see or understand what is happening inside their own systems. Moving on to Section 2, applying a systems lens. To escape this snarled mess, we have to completely change our perspective. We've got to abandon the feature lists. Stop trying to compare vendor categories line by line or, checking off boxes on some RFP. Instead, you need to shift your focus to strengthening organizational feedback loops. The ultimate goal of modern software delivery is to learn fast. Think of it like a chef in a high-end restaurant. If the chef is cooking this complex, multi-course meal, but is completely barred from ever tasting the soup before it goes out to the dining room, they can't adapt. They can't add salts, they can't adjust the heat, and they have no idea if the recipe is actually working until a customer angrily sends it back to the kitchen. Software is exactly the same way. Your goal is not just to buy a tool. Your goal is to strengthen the information flows within your organization. Observability is simply the mechanism that connects cause and effect. If your teams cannot accurately taste the soup, if they can't sense what is happening in the system in real time, they cannot learn, and they certainly cannot adapt. Which brings us to Section 3, development and operational loops. Let's map out the first primary loop that dictates how most organizations operate today, the development loop. Now, this loop is incredibly tight. It's highly optimized and incredibly iterative. A developer writes code, runs local tests, learns from those tests, builds some more, gets a peer review, and then they merge. This entire cycle revolves around the "I wrote this" mindset. Developers are validating their intent in a sterile, perfectly controlled local or staging environment. But notice exactly where this loop ends. It abruptly stops the exact moment the code is merged into the main branch. The developer has proven that the code works on their machine, but they do not actually know what happens next. The The code is now headed out into the wild, where it's going to interact with unpredictable data shapes, network latency spikes, and weird, unprecedented user behaviors that were literally never accounted for in that pristine staging environment. Now let's contrast that with a second loop, the operational loop. Code is deployed to production, and then absolute silence. It is an entirely open loop. The operational feedback only kicks in when the 2 a.m. pager goes off. Imagine that dread for a second. The alarm blaring in the middle of the night, adrenaline spiking, bleary-eyed engineers scrambling to pull out their laptops. A customer is complaining, the support queue is blowing up, and someone has to frantically investigate a broken system. They have to blindly grep through thousands of logs, try to figure out what went wrong, and hopefully fix it before the company loses too much money. There is a massive, terrifying gap in visibility between the moment of deployment and the moment of catastrophic failure. The system only speaks to you when it is actively on fire. When we put these two realities side by side, it highlights a stark, incredibly dangerous disconnect between developer intent and operational reality. Your development loop is entirely focused on, I wrote this, and it stops cold at the merge. Your operational loop is entirely focused on, the pager is going off, and it only starts when something is already broken. These isolated, disconnected loops create a massive blind spot in software delivery. Most developers do not actually know how their code performs in production because they don't have the tools to easily ask questions without waiting for a crisis. And the cost of this blind spot? It is immense. It slows development velocity to an absolute crawl, it breeds this culture of fear and hesitation around Friday deployments, and it rapidly burns out your best engineers because they are basically being forced to operate complex distributed systems entirely in the dark. Let's look at Section 4, Finding the Missing Loop. This profound disconnect we just talked about brings us to the core issue plaguing modern engineering teams. We can define this crucial gap as the missing loop. It's a consistent feedback loop connecting the developer's concern of, I wrote this, directly to the realization of, I can see and understand exactly what it did in production. It is the missing bridge. When you close this gap, you connect a developer's original intent with the actual complex reality of how their code performs in the wild. I mean, imagine what it feels like for an engineering team to actually have this bridge. It is pure instant gratification. A developer merges their code, it deploys, and within seconds, they can pull up a highly detailed visualization of actual user traffic flowing through their specific new feature. There's no guessing, there's no waiting for the customer success team to complain. They can confidently deploy, instantly verify, and iterate. But what happens when you don't have this bridge? What happens when developers try to understand production but have to fight through slow, clunky, siloed tools just to get basic answers? Well, when curiosity is punished by opaque systems, organizational learning literally grinds to a halt. Think about a developer who just wants to check if their new database query is efficient. They open their monitoring tool, build a query, hit enter, and then wait. If it takes 30 agonizing minutes for that dashboard to load, or worse, if the query just times out entirely, that developer will simply close the tab. They'll stop asking. They'll stop caring. The opacity of the system becomes a self-reinforcing cycle of institutional ignorance. Developers just accept that production is a black box. Meanwhile, the organizational costs, measured in wasted engineering hours, degraded performance, and sheer organizational friction, they just compound rapidly behind the scenes. We're looking at two very different realities here, the flywheel versus the doom spiral. These are amplifying feedback loops, and they dictate the entire culture of your engineering organization. Over on the left, we have the flywheel. This is the reality when that missing loop is fully closed with good observability. Developers deploy a change, they immediately observe the effect of their cause in production, they learn exactly what happened, they tweak the code, and they deploy again. It's a self-correcting, continuously improving, positive direction. On the right, we have the doom spiral. Without observability, the loop is left wide open. A cause creates an unseen effect, errors and latency compound quietly in the background, institutional knowledge degrades into relying on shallow pattern matching or tribal knowledge, like just asking the most senior engineer to fix everything, and eventually it spirals into a massive, unexplainable, catastrophic failure. The difference between a virtuous cycle and a complete death spiral isn't the intent or skill of your developers. It is strictly a matter of whether the system can see clearly enough to correct itself. Section 5. Context, precision, and cardinality. So how do we actually make sure we are building that flywheel? To effectively close that missing loop, we really need to examine the power of the data itself. I want you to focus on this number for a second, 30. Imagine you're capturing telemetry data from your applications, distributed traces, or canonical events, and you currently attach 29 fields of contextual data to a specific event. This might be things like the user ID, the browser type, geographic region, endpoint HTTP status code. If you add a 30th field, let's say a custom business metric like shopping_cart undersize, you aren't just getting one more isolated piece of data. That 30th field makes your data exponentially, not linearly, more powerful. It creates an exponential explosion of searchable space. Every new dimension you add multiplies the distinct ways you can slice, dice, and group your production data to find exactly what went wrong. That mathematical reality? It's known as combinatorial scaling, and it is the absolute secret engine of real observability. Think of it kind of like playing the classic board game Guess Who. If you can only ask the system about hair color, it is going to take you forever to find the culprit. But if you have high context, high cardinality data, you can ask about hair color, glasses, hats, eye color, and whether they have a mustache, all at the exact same time. You find the culprit instantly. High context data enables exponentially more combinations and subsets of dimensional detail. This extreme cardinality allows your engineering teams to achieve the microscopic precision necessary to understand any novel system state. When a bizarre, unprecedented error occurs in production, you don't have to guess. You can slice through that high-context data to find the exact combination of variables. For example, let's say premium users in Germany using version 2.4 of your iOS app, trying to check out with a shopping cart size over $500, that are failing. You completely move from guessing to knowing. And finally, Section 6, a strategic organizational investment. Now that we understand the mechanics of these feedback loops and the high-context data required to fuel them, we must completely reframe observability. It is not a technical debugging tool. It is a strategic organizational investment. Observability is the sense-making layer for complex socio-technical systems. When you have high-quality, granular data, it acts as a real-time business intelligence apparatus to answer critical cross-cutting questions. Let's walk through what impact by user cohort actually means. Imagine you launch a massive new feature. Instead of just looking at global CPU spikes and hoping it went well, precision observability lets you instantly isolate the performance of that new feature, specifically for your most valuable enterprise tier customers. You can analyze business outcomes based on whether a specific feature flag is toggled on or off. You can pinpoint tiny latency regressions down to a specific API request path before they ever impact a user. And you truly understand application behavior under real punishing production load. These aren't just technical IT metrics, they are mechanisms that drastically reduce business uncertainty. They allow your entire business to move fast without blindly breaking things. I'll leave you with this final provocative thought. Observability fundamentally inherits the properties of the code you observe. If you treat your code as a pure cost center, well, observing it will always just feel like another frustrating IT tax. But if the code you write is an investment, if software is the core engine of how you generate value, how you serve your customers, and how you exist and compete as a modern business, then observability is the ultimate investment in understanding your complex systems. So you really have to ask yourself, are you just paying for a cost center? Or are you actively investing in a sense-making apparatus that accelerates how fast your entire organization can learn? Thank you so much for joining me for this explainer. I really hope this gives you a powerful new lens for your observability strategy.